at discrete probability distributions, just kind of the basics of them. So after this video, you'll be able to draw a histogram, describe its shape, calculate mean, variance, standard deviation of discrete probability distributions, produce a probability distribution using theoretical probabilities, and find expected values in the situation. This chapter uses new libraries called ARM and weighted discrete stat. They're just other packages we have to use. So we're going to go into random variables. This is kind of taking your categorical variable and coming up with a variable that will help you count or deal with something you're working with. So suppose you are measuring, your variable is measuring if a prairie dog has fleas that cause bubonic plague, and you're interested in the number of prairie dogs with the fleas that cause the bubonic plague. This new information can be called a random variable because you're caring about that number. The random variable is like the variable, but for qualitative variables, that random variable is usually counting your variable. For quantitative variables, variable can also be called a random variable, and we will not do that for right now, but we will get into it. So random variable created from a qualitative variable or categorical variable, discrete random variable. A random variable created from a quantitative variable is what we call continuous random variable in most cases. If you have a discrete random variable, remember that it is where you are counting your quantitative variable, your categorical variable, and you list all of the values that the random variable can take on with their corresponding probabilities. Then you have what we call a discrete probability distribution. So here's an example. How many times does a person need to see an ad they see on TV before they purchase the product? This table contains data collected from the National Infomercial Marketing Association on what percentage of people purchase a product after seeing an infomercial for the different times. So if you saw it one time, 27% of the people purchased. Saw it two, 31% purchased. Three, 18%. Four, 9%. And five or more is 15%. The category five or more will be treated as just five, just because we can't work on that. So let's state the random variable in this case. In this case, the variable would equal the number of times a person sees an commercial before buying the item. I should mention that if somebody never purchases, they would be in that 5+ category. The formulas for it, I'm going to show you the formulas. We're not actually going to use them. We're going to use everything in R, but I wanted you to see what it is. What you do with these is you actually take and add up your probabilities times each of these. So you multiply these all together. So I'm missing a P in there, an X in there, sorry. So you're gonna, I don't know why this is having issues. Take that out, okay. So you're gonna sum up X times P of X, and that will get you your expected value. Then your variance is done a slightly different way. It's a pretty involved process. And then you take each of your x's, subtract off your means, and then you multiply by the P of X. Standard deviation is just the square root of that. R is a little bit easier. You're going to type in your variables. You're going to type in your probabilities. That C stands for combining them into one thing. Then we're going to do a discrete histogram using this command. I'll explain what these are when we do it. And then here's your mean and your variance and standard deviation and how you calculate those. This is only using these packages. If you don't use these packages, you can't. So first we're going to do is put the probability distribution into R. So I'm going to call these number as my variable, just to give it a name. And then I'm going to combine them. So this, remember, I'm going to assign it to combining, oops, didn't need to do that. Combining C of 1, 2, 3, 4, and 5. Then I'm going to do my prob. I call it prob. You can call it probability. You can call it whatever you want. These are your names you're giving things. You can call them anything you want. Notice these are all put in as decimals. Make sure you also keep them in the right order. Now I'd like to draw a histogram of this. So the first thing we do is insert an R chunk. And this, oops, this is discrete. And I believe it's discrete histogram. So we're going to do the discrete histogram. And then we need to first put in our random variable number. And then we need to put our probability, prob. And this actually will work. Just the way it is, it'll produce a graph. Oh, I forgot to run this. Helps to run this and get those in there. Notice here, it didn't put them in as data frames. It just put them in as values over here. Now I can run them. And it did actually work. And you get this graph. But we'd like to do a little bit more with the graph. We'd like to put some things together. First off, I really like the bars touching. So the way we do that is we call it bar.width equals 1. And now the bars will touch. The other thing is I would love to have a title. So I'm going to actually call that um and you can't use title on this, unfortunately, because this is a different package. The title is main. And so you type in main and then you say that you're going to have the number of times to see commercial, commercial before buying. And then I probably would call my X lab, not just X. I want to give it a name. X is what R puts in there, but I want to give it a name. So I'm going to probably call it number of times. And then I like probability on the y-axis, so I probably won't change that. Now I run it, and I can now see a little bit more of my graph. The shape of this looks a little bit like it might be what I would call skewed right, because then we have a little bit lower stuff down here, higher stuff over here. So on the right is lower down, so I would probably call this skewed right. Remember, the skewness is this is what's causing it to be skewed, is this material on the right, not the big stuff on the left. The big stuff on the left is where everything is. The right is what's causing it to be skewed. Now to find the weight then mean, again, insert our chunk, and then I'm going to do w dot mean, and I'm going to do it of my x, which is my number, and then it's called mu, it actually is my prob, and then I just can run that. And there's my mean. So 2.5 times before somebody actually purchases. That gives you an idea of how much you have to buy of your ads. Then we want to do the variance, which is w.var. And again, number and prob. And then I might as well this time I'll do w.sd. And again, I'll do number and prob. So run that. And the standard deviation looks kind of small. So 2.5 plus or minus 1, 2, almost 2. Unusual events. Determine if an event is unusual. You're looking at the number of successes, the X number of successes among N trials. And the probability of X or more successes being less than 5%, then you consider that X value an unusual high number of successes. Another way to think of it is if the probability of at least X successes among the N trials is less than 5%, then the event is considered unusual. Same thing with less success. If you were doing unusually low, you'd be looking at less success. It's still less than 5%. So now let's find the probability of taking 4 or more cues per person to actually buy an item. So let's find that probability. So we're looking for the probability of 4 or more. Well, if I go back up to my data here for a moment, what I noticed is 4 or more means 4 or 5. So these two together would be it, would be the answer. And all I gotta do is add those together. If I get my values, those values were again way up here at the top, 9% and 15%. So all I have to do is add in 9% and 15% together. And that's equal to 24%. Since 24% is not less than 5%, this is not unusual. Let's say I want to create a probability distribution. Consider the experiment of rolling a pair of dice and finding the sum. Create a probability distribution of that, then draw the picture of that. So again, I'm going to kind of create a table. If I think about dice, there are certain type sums I can get. I can get 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Can't get a 1. Can't get more than a 12. So I'll probably do 12 rows, but I only really need one column. No, actually, I needed two columns. I apologize. So insert a column. Okay. So my first column is going to be the sum. My second column is going to be the probability. So again, I can get 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 as my sums. So let's think about getting a sum of 2. So you can roll 2 dice. There are 6 sides on each die. So there are 36. If you think of 6 on one die and 6 on the other, there's 36 different combinations you can think of having. There's only one way to get a sum of 2. You have to get a 1 on the first and a 1 on the second. So it's 1 out of 36. Getting a sum of 3, you can get it as a 1, 2, or you can get it as a 2, 1. So there are 2 different ways to do this. So that's 2 out of 36. Sorry, 36. I meant to write 36 in the top one. 4, same thing. You can get a 2, 1. I'm sorry, get a 1, 3, 2, 2, or a 3, 1. There are 3 of those. 5, 1, 4, 2, 3, 3, 2, 4, 1. There are 4 of those. 6, I believe there's going to be 5 of those. If you notice, we're kind of getting this pattern here. 7 seems to have 6 of them. So now let's think about 8, though. Does 8 have 7 of them? But you can't get a 1, 7. You can get a 2, 6. So you can get 2, 6, 3, 5, 4, 4, 5, 3, and 6, 2. So there's 5 different ways that happens. 9 would have 4 different ways. If you notice, the numbers are getting smaller. 10 would have 3 different ways. 11 has 2 different ways. And a 12, you have to get a 6 and a 6. So there's our probability distribution. Don't need this extra row, so we'll just delete that row. Okay. So now I'd like to do a histogram of this. So what I have to do is I have to, again, create my sides, my variables. So sum, I'll call the one variable. We're going to combine numbers 1, I'm sorry, not 1, because there's no 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I might put spaces there just for readability. You don't have to put the spaces there. It just makes it easier for me to read. And then I'll put my probability. And I'm going to combine those together. And I don't need to go calculate what these are. I don't need to know what those numbers are. R can do that for me. So I can just type in 1 divided by 36, comma 2 divided by 36, comma 3 divided by 36, comma 4 divided by 36, 5 divided by 36. And then we stopped at 6, started coming back down again. So 5 divided by 36 again. 4 divided by 36, 3 divided by 36, 2 divided by 36, and 1 divided by 36. All right. So now that we have those in there, we can get our histogram. Discrete histogram. We're going to do sum, probability. Again, I want my bar dot width to be 1. And I'm going to do my main is going to be sum on the dice. And I probably would like my X lab to be sum. And then I can go ahead and calculate my W dot mean of my sum and my probability. I can do my W dot SD of my sum and my probability. If you want the variance, W dot var of your sum and your probability. And then I can just run this, and it'll run all of that for me. This is a very nice symmetric graph. I can find my mean, my standard deviation, and my variance. Basically, a mean is the expected value. So we've been doing expected values, but we're going to do a little bit more with expected values. Expected value is kind of where you expect the things to go in the long run. So in the long run, how much do you expect to get out of it? Gambling, games, insurance, extended warranty, and other types of these experiments are using expected value. That's actually how your insurance company figures how much to charge you is based on the expected value, and then they add in how much profit they want to get. So we're going to do a problem here of expected value of a craps bet. In the game of craps, there's a bet called Yo. Yo is where if you win, if the shooter has an 11, on an $8 bet, you will have a net gain of $120. You're given 128. But you can get back the $8 you bet. So you actually only gain 120. The probability of winning is 2 out of 36. We actually saw that before. The answer that you are to ask is, what do you expect to win in the long run? So again, we're going to make a little table here. So if you lose, what do you actually gain? Well, you lost that $8. It went away from you, so it's -8. Your probability of losing is 1 minus the 2 out of 36, which is the probability of winning. Your net gain, if you win, you're going to get the $120. You get 128, but you had to pay the 8, so you really only gained $120, and you have a chance of 2 out of 36 for that. You can calculate this by just multiplying these all together and then adding these up, and that will give you your answer. I'm going to actually use R to do this, but I can actually just multiply this times this number, come up with this answer. If you want this 2 out of 36, 1 minus 2 out of 36 is 34 out of 36. So you can multiply 34 out of 36 times -8, 2 out of 36 times 120, add them together, and that will give you your expected value. Again, I'm going to let R do this for me because I can. So I'm going to insert that. And I can let R do all those calculations for me. So 8 times 1 divided by 2, 1 minus 2 divided by 36. It will calculate that for me. And the other one I want is 120 times 2 out of 36. So I run that, and it tells me this one I have to remember is negative. Actually, I could have put the negative in there. Let's do that. And so I get negative 7.556, let's say. And this one is 6.667, let's say. And add those together. So now I want to add them together. So I'll just change this a little bit and add them together. And I get negative 0.889. So since it's negative, granted you can't earn 88 cents, but since it's negative, it means that you are losing. So your expected value is that you will lose 88 cents or 89 cents in the long run. And the most important thing is you are losing. All right, so let's say we have another big game. Instead of placing $8 bet on the pass line, which is betting on the shooter to win, the probability of winning is 244 out of 495. You want to find out what you will win or lose in the long run. If you bet $8 on the pass line and you win, you are given $16, which means you actually only win $8. You receive your original bet of $8 back. So if you lose, you had to pay that $8. So that $8 went away from you. Your probability of losing is 1 minus your probability of winning. If you win, you actually only gain $8, and your probability of winning is 244 out of 495. Now I'm gonna actually let Art do this whole thing for me instead of the piecemeal I did in the last example. So now what I'm gonna do is I'm gonna have my gain, and that's gonna be combining the numbers -8 and the number 8. And then I'm gonna have my probability. And I'm gonna put in my 1 minus 244 out of, oops, I forgot my C. C, 1 minus 244 divided by 495. And then my other one was 244 divided by 495. And I just noticed I typed that wrong. So let me go fix that. And then I'm going to do a weighted dot mean. W dot mean of my gain and my probability. Oh, I do have an equal sign. Oops. Totally messed that one up. Okay. I can't spell. Why didn't color code? Color number. So right. Okay. So and 1 minus. There we go. I knew I messed up because it was a positive, and I don't think you get a positive out of this. I obviously am having issues typing today. There we go. All right, so you lose, because it's still negative, you lose 11 cents. So your expected value means you're going to lose 11 cents in the long run. Since you lose less on this one, this would be the better way to win this, to bet on the pass line than to bet on yo, because you lose less in the long run.